Okay, welcome to chapter 4, sorry about that, which is titled Strong Acid, Strong Base. How I do this problem will be identical for either one. Now, obviously, I'm giving you HCl, which is a strong acid, but the approach is going to be pretty much the same if it were a strong base, like sodium hydroxide, calcium hydroxide, lithium hydroxide, etc. Okay? So the first thing we're going to do, identify major species. Now, when I say that, yes, okay, I get it's HCl, okay? But it's not that. It's what is HCl? Well, HCl is a strong acid. This is the important part, knowing that it's a strong acid, okay? This part is what will help us solve all of these problems throughout this entire unit. Knowing that it's a strong acid means it behaves a certain way. So this is super important, all right? So my species, HCl, and it's a strong acid. And I want to know HCl, H plus, OH minus, pH, and pOH. And then I want you to tell me if the solution is acidic, basic, or neutral. And I give you a volume, a molarity, and then I tell you you dilute it. Okay, so I'm taking an acid and I'm diluting it. So we identified the major species, it's HCl. Okay, write out the reaction. Well, if it's just HCl in there, HCl, one-way arrow, because it is strong, breaks down into H plus and Cl minus. Okay, now we have to do some math, because what's going to happen is my acid is going to become diluted. It's not going to be 0.2 anymore. So how do you do the dilution? Well, what's the dilution equation? M1V1, M2V2, right? So M1 is 0.2 molar. V1 is 50 milliliters. Sorry about that. M2, I don't know. Right? That's what we're solving for, what the new molarity is. And what is V2? Is it 200 or is it 250? Well, this word diluted 2 means this is your final volume. So final volume is 200 milliliters. Okay? So you divide both sides by 200 to get the new molarity. And I'm pretty sure it is 0.050 molar HCl. Okay? So that's what we have for the concentration of the acid. All right, so the next step that tends to be what comes next after you have to do math is write out the equilibrium expression. The thing is, this is not going to equilibrium because it is a strong acid. So this is not an equilibrium expression. It's just a reaction. HCl 100% ionizing into H plus and Cl minus ion. So what does that mean? It means at the end of this, because it 100% ionizes, you should have no HCl intact. It should be all hydrogen ion and all chloride ion. And look, if it's 0.050 molar HCl, it's 0.050 molar H plus and 0.050 molar Cl minus. Why? Well, because they're in a 1-to-1 ratio. If there was a 2 in front of here, pretend there's a 2 in front of your hydrogen ion. What would this have been? Like if it was a diprotic, let's say. This would have been 0.1. It would have been 0.05 times 2 because there's 2 of them. Okay? So just be careful of the ratios. So look, we've got the H plus ion. So the HCl concentration should be 0. You shouldn't have any of it. The H plus ion is 0.050 molar. So I'll try to write above here. 0.050 molar. Okay? All of these other things we could solve for in any order we want. There are actually so many different ways to go about getting the rest of these. I think what I'm going to do is I'm going to find the OH minus concentration next. So here's what you got to remember. This is from chapter 3. H plus concentration times OH minus concentration always equals 1.0 times 10 to the negative 14th. Okay, so you plug in your OH minus. It's 0.050. That's your H plus. Did I say OH minus? Sorry if I did. Okay? This is basic algebra. Okay? You divide both sides by 0.050, and OH minus comes out to be, I don't know because I don't have my calculator ready, so hopefully you do. So you take 1 times 10 to the negative 14th. Okay? Divide by 0.050, and you get, 2. 13? 2 times 10 to the 0 times 10 to the negative 13th molar concentration. So I just got my OH minus. Okay? I know I'm running out of room a little bit, but what is the pH equation? Well, on your equation sheet, pH equals opposite the log of H plus concentration. We know H plus concentration, it's 0.050. So pH equals opposite the log of 0.050. So you plug that in your calculator. Opposite the log of 0.050. It ends up being pH is 1.30. Let's talk about sig figs. Okay, things are going to get weird. So this is a 2 sig fig number. Well, that's because we had a 3-digit, a 2-digit, and a 4-digit, so 2 sig figs is what we should have gone with. The rule of logs is that sig figs don't start counting until after the decimal. So like this one right here doesn't even count as a sig fig. This is 1, 2 sig figs. Those are your 2 sig figs. This is technically a 2 sig fig number. I know it doesn't look like it. It's just the rules of logs. PHs and POHs will be weird like that. You follow how many decimal places out to tell you the sig fig. So this is 2 sig figs. Okay? Well, sorry. I'll go down here. I know I'm running a little bit out of room. Make yours neater. Okay? How do I get POH? Well, that's easy. Once you have pH, remember this equation? pH plus POH is 14. So 1.30 plus POH is 14. So you take 14 and you subtract 1.30 and you get 12.70. 2 sig figs. Okay? Now, notice the pH is 1.30. Well, what do we know about pHs in the 1 range? Definitely acidic, right? It asked whether the solution was acidic, basic, or neutral. Well, thank goodness, right? Because hydrochloric acid is an acid. So I'm really glad we ended up with an acidic pH. Okay? So the main thing about strong acids and strong bases is that they 100% ionize into their ions. If this was a base like sodium hydroxide, this would have been NaOH and it would have been Na plus OH minus. You can do all of this work with OH minus to figure out pHs and POHs. Okay? Whatever the concentration, this is purely of the ions is. It's nothing more complicated than that. When we get to weak acids and weak bases, it's not going to be this simple where you will just have the molarity and then you use the molarity. It's not going to be as simple. This only works when they are strong. Okay? All right, that's the end of this one.